My name is Franklin Joyce, and today I'm going to be telling you about germanium. First of all, what is germanium? I'm going to be talking about several key characteristics that make up the element germanium. Its physical properties, its abundance, its reactivity, some special properties and uses germanium has, and germanium's history. Some of the physical properties of germanium. It's a lustrous, hard, grayish white metalloid. It has like a silvery kind of shiny hue to it, but it's actually a metalloid, which means it's in between like a metal and a transition metal. The abbreviation is GE, atomic number 32. It has a density of 5.323 grams a milliliter or grams a centimeter cubed. Its boiling point is 3,106 Kelvin. And its melting point is 1,211.4 Kelvin. It has an atomic weight of 72.630 grams, and its electron configuration is Ar3d10, 4s2, 4p2. Germanium is ranked 53rd among the most abundant elements in the Earth's crust, and it's estimated to exist in 7 parts per million in the Earth's crust. The top producers of germanium are China, Russia, the U.S., and Belgium. And an interesting fact about germanium is that it's not actually mined itself. It exists as impurities in other elements, which is one of the reasons that it was only discovered in the late 1800s. But it's not actually, normally germanium is discovered when they're refining other elements, other metals, and that they discover germanium as an impurity, and then it is extracted from other metals and then used as whatever they need germanium for. Some of its special properties: pure germanium is used as a semiconductor, and in fact all the way up until the 1950s and 1960s it was the only semiconductor metal that was used. All of our semiconductors for the most part were made of germanium until we were able to purify silicon to the point that we could use it as a semiconductor. Its main uses today are in infrared optics, fiber optics, polyethylene terephthalate. It's used in electronic and solar equipment, as phosphors, metallurgy, and organic uses. Its reactivity: germanium is a very, very stable metal. It does not react at room temperature with anything. It does not react with water. It will react, though, with oxygen, chlorine, and bromide if you get it to very, very high temperatures. It doesn't form an acid or base, but it will dissolve in sulfuric and nitric acids if you heat sulfuric or nitric acids to extremely high temperatures. The really interesting thing about germanium is that it was actually predicted to exist by Dmitri Mendeleev when he created his periodic table. And he actually, after he created his periodic table in 1869, germanium wasn't discovered until 1886. And so for a very long time, we didn't know what this element was, but it was predicted to exist by Mendeleev, and when it was discovered, it was amazing that the metal was very, very close in atomic weight, very, very close in density, and very, very close in chemical properties to what Mendeleev had predicted it would be. It was discovered in 1886 by Clemens Winkler, and it really was not used extensively for anything until World War II, when radar became extensively used, and it was used in some semiconductors and electrical equipment extremely extensively after that until the development of silicon. 1950 used as transistors, and then in 1960 with the invention of silicon it shifted more into being used for infrared technology. And then in 2000 we see some special uses of germanium in photovoltaic cells and in light emitting diodes. So I just wanted to talk with you a little bit about the element germanium and some of its history and where it was found at, and some of its physical properties. Thank you.